Solve the equation. Express irrational answers in exact form and as a decimal rounded to 3 decimal places. Rounded to 3 decimal places. And express irrational answers in exact form. Now these are very important points. You're told not to use a calculator. Instead, leave irrational answers in exact form. That's very important. Now the equation you want to solve is 3 to the power x equals 4 to the power 1 negative x. And then the next equation we're going to solve after solving this is 3 times 5 to the power 2t negative 1 equals 78. So let me start by writing question 10. You have 3 to the power x equals 4 to the power 1 negative x. Now looking at this exponential equation, what we intend to solve is at the position of the exponent. It's at the exponential position, and then it's very impossible to work with an equation like this. Before I take any step further, my aim is to ensure that all unknowns are at the base level. They should be at the base level. Now the best operation to carry out in such cases is to take the logarithm of both sides. So what I'm going to do now is I'm going to take the natural logarithm of both sides. So that's going to be the ln of 3 to the power x. That's of 3. So let's leave the power x equals the ln of 4. Just want to make things a little fancier so that you clearly understand the way the whole things move. So when you take the ln of both sides, you observe that the ln has a base of e. So now you have e3x. You have 3 things in a row. So by the law of logarithm, it implies that we need to bring this to this side, and then you have e4 1 negative x. By the law of logarithm, we need to bring this to the other side there. So this becomes x, the ln of 3 equals 1 negative x, the ln of 4. Now we can continue by solving. So what we have here is x, the ln of 3 equals, now this is 1 negative x times ln of 4. It's as if you're expanding something. So what you have here is the ln of 4. The ln of 4 times 1, that's going to give you the ln of 4 minus, then x times the ln of 4 is going to give you x ln of 4. So I only expanded this, just like you would expand a times 1 negative x. That will be a negative ax, just normal expansion. So the next thing is you want to collect like terms. So you have x here and then you have x here, so you bring it to this side. So this becomes x, the ln of 3 plus, so this is x, so I added x ln 4 to both sides, plus x, the ln of 4. So this equals the ln of 4. So this is what we have. Now the next step is, since x is common, you can bring x out. So you have the ln of 3 plus the ln of 4. So this comes out here equals the ln of 4. And then since what we intend to solve is we want to solve for x, so we're going to divide both sides by the ln of 3 plus the ln of 4. So you divide by the ln of 3 plus the ln of 4, and you divide by the ln of 3 plus the ln of 4. So this automatically crosses out. So what you have left is going to be x equals the ln of 4 divided by the ln of 3 plus the ln of 4. So this is your final answer. We've been told not to apply or to use a calculator to solve any of this. The next thing we want to solve is 11. Question 11. Now that says that 3 times, so you have 5 to the power 2t negative 1 equals 78. So again, to highlight this, what we intend to solve is t. Now before I begin to carry out any step, what you'd observe is before I can solve for t, I need to begin to clear out all the barriers around t. Now the first barrier is 3. How do I remove 3 from here? I have to divide both sides by 3. So the 3 here goes off. So what you'll be left with is going to be 5 to the power 2t negative 1 equals, now 78 divided by 3 is going to give you 26. So again, since what we intend to solve is we intend to solve for t, and then t is at the exponential level, before you begin to carry out any operation, you should ensure that all the unknowns in the algebraic equation should be at the base level. So the best operation to carry out is the same operation we carry out here. So you're going to take the natural logarithm of both sides. So this is 5 to the power 2t negative 1 equals the natural logarithm of 26. So again, when you carry out the natural logarithm, it displaces what you have here. So this comes here, it becomes the coefficient. So you're going to have 2t negative 1, then the ln of 5 equals the ln of 26. So this is a number, so like you want to expand. So what you're expanding now is ln 5 times 2t. That's going to give you 2t times, so we can decide to just make this fancier. This is going to be ln 5, then negative, now 1 times ln 5 is going to give you the ln of 5. So this is equal to the ln of 26. So we can add ln of 5 to both sides, the ln of 5. So what you'd obtain here is just going to be, so this is plus, this will be ln of 26 plus the ln of 5, and then here the ln of 5 crosses here, so you have 2t the ln of 5. So since what we intend to solve is t, I could just decide to just make my t a little fancier. So to write this equation out, so what we have here is 2 times t ln 5 equals the ln of 26 plus the ln of 5. So we want to solve for t. So to solve for t, we divide both sides by 2 ln 5. Divide both sides by 2 ln of 5. So 2 crosses out here, then ln of 5 crosses out. So finally our t is just going to be the ln of 26 plus the ln of 5 divided by 2 ln of 5. So this is our final answer. So again, the question says that we should leave our answers in exact form, and as a decimal round to 3 decimal places. Well, in the solutions we obtained there was no decimal, so we're going to leave our answers in exact form. So that completes the problem.